this video, we will learn about the explanation of Charles' law on the basis of kinetic molecular theory of gases. So we know that according to the kinetic molecular theory of gases, the average kinetic energy of the gas is directly proportional to the temperature. Means if the temperature increases, the kinetic energy increases and vice versa. So what happens is when we increase the temperature, let's say here we are having this beaker, we are heating it, so the kinetic energy of the particles inside will increase and these molecules, they will move with greater velocity in all the directions, means their speed or velocity will increase. Now if the dimension of the container does not change, these molecules now will strike the walls of the container or the vessel with more impact or more frequently. This will increase the pressure. But if the pressure is kept constant, like here we are having this piston, so the pressure is kept constant, so the volume has to increase. Here we can see that the volume of the gas has been increased once we have heated it. So we can say that at constant pressure, the volume of the given mass of a gas is directly proportional to the absolute temperature. Absolute temperature means the temperature is in Kelvin scale, which is in accordance with the Charles law. Now we have the practical significance of Charles law. We have seen hot air balloons in sports. So the use of hot air balloons, it is an application of Charles law. So according to Charles law, we know volume is directly proportional to temperature, means volume increases on heating. So a gas expands on heating. So we can say for a definite mass of a gas, a larger volume corresponds to lower density, because if the volume increases, here we can see we are heating the air inside the balloon, so the volume of the air increases and it becomes less dense. So we know that hot air is less dense or lighter than the cold air. This will make the hot air balloon rise up by displacing the colder air of the atmosphere. This makes the balloon go up. So this is an interesting application of Charles law. Now we have a question on Charles law. It says at what temperature will the volume of a gas double itself, the pressure remaining constant. So let's say the initial volume is V liter, because it's not given to us, we have assumed it to be V. Now the temperature should be on Kelvin scale while doing the calculation. So V1 is V liters, and according to the question the volume is doubling itself, so it will become 2V. Now T1 is 0 degrees Celsius, means 273 Kelvin, so we have to find T2. Now according to Charles law, V1 upon V2 is equal to T1 upon T2. So while putting the values, we will get T2 as 546 Kelvin. So from here, the temperature is coming out to be 546 Kelvin. But the question is in Celsius scale, we have to answer it in the Celsius scale. So we'll subtract 273 from it. So on Celsius scale, the temperature will come out to be 273 degrees Celsius. Means at this temperature, the volume of the gas will double itself. So I hope it is clear to you. Thank you.